Hey everybody, I wanted to make this video to show you how to solve 2x2 systems of linear equations by using algebra, right? In the last video we talked about, or in the last topic I should say, we talked about estimating it and doing it by graphing. There's a better way. There's a way that actually involves solving, so that's what we're going to learn to do here. So let's do that. Get a whiteboard going here. All right, so the first thing I want to do is tell you about the two methods. They're called substitution and elimination, and they're aptly named. I'm gonna start with elimination. That's the one that people tend to prefer. And so the basic idea of solving by elimination is to get rid of a variable. So yeah, let's see an example here. So the one I'm gonna start with is this: 3x minus 2y equals -9, and x plus 4y equals 11. X plus 4y equals 11. So the basic idea of elimination is that you want to add the two equations together and get a variable to cancel out. Now, there's two things there that I want to point out. You may be saying, can I really just add equations together? Like, is that a thing I can do? And the answer is yes. So here's why. Here's the idea. If I were to add these together and add these together, the thing I would get would be 4x. Here, I'll just do it, and we'll see why it's not good here. So we'll get 4x plus 2y equals 2. And so I've got another equation, and the real question is that equation valid, right? Is it actually the case that the left side equals the right side? And it does, and here's why. So think about it this way. So my top equation here is an equation. That means that the left side and the right side are equal to each other. This is also an equation where the left side and the right side are equal to each other. So if to the left side I add this, and to the right side I add that, that's okay because this and this are equal. We know they're equal because this is an equation. And so I actually am adding the same thing to both sides. So it is okay to add two equations together. You can also subtract two equations, multiply or divide. Dividing is going to be relevant to us when we get to logarithms. But it is actually okay to do that. Now, I don't want to do exactly what I did here because I didn't get rid of any variables, right? I've still got x's and y's and a number on the other side, and that's the situation I was in already. So instead, here's what we're going to do here. First, I'm going to erase all that stuff because I don't want to do that. Oop. All right, so here's what I'm actually going to do. What I want to have happen is I'm going to add straight down, like that's the plan. But when I do that, what I want to have happen is I want one of the variables to go away. I want it to go to 0 when I add them together. And there's a couple ways to do that. I can either make x go to 0 or y go to 0, and I can always do either one. You just want to pick the one that's easiest. And to be honest, they're both about equally easy here in the following way. So what I'm going to do is I am going to multiply both sides of my top equation by 2. And the reason I'm going to do that is that will make this a minus 4y. And when I add it to the 4y here, they'll cancel, right? That's my goal. So that's what I want to do. I'm going to multiply both sides of this equation by 2. And you might ask yourself, well, how did you know to multiply by 2? And I'm just picking whatever number to multiply by will cancel out one of my variables, right? And it turns out I could have multiplied my bottom equation by 3 or by -3, and that would have given me minus 3x to go with the 3x, and those would cancel. So I could have done that one too. So yeah, you can always do either one. Just multiply by something so that when you add them together, one of the variables will cancel in the resulting equation. So I'm gonna rewrite this whole system here. So this whole system now looks like this: 6x minus 4y equals -18. And the bottom equation I didn't do anything to. X plus 4y equals 11. And now when I add them together, I end up with 7x. The 4y's cancel, and this equals -7. Aha! That's easy to solve. This is my goal. This is what I'm trying to get, is some equation with just one variable that I can easily solve for, right? So I divide by 7, and we get x equals -1. And great, we've got the answer. Not quite, actually. Because if you recall, this is a system of two linear equations. What that means is that you have like a point where they meet, right? And our goal is to find this point. It's to find the point that is on both lines. And I haven't quite done that yet. All I've got is x. And this point has an x and a y coordinate. So I still need to find y. So what I can do is I can take this value for x and put it back into either of my starting equations. And the reason I can do that is my starting equations both go through the solution point, and at that point they have this x value. I know what the x value is at the point I'm looking at, and I realize x equals -1 does not fit where I drew this point. This was just two random lines, not these two lines. So I can take this x value and put it into either equation to find whatever the point is where they intersect, because I know the intersection is at x equals -1. Doesn't matter which one I use, choose whichever one you feel like. I'm going to choose the second one. I got x plus 4y equals 11. So if I have x plus 4y equals 11, then I can put in -1 for x, add 1 to both sides, and so y has to be 3 because 4y is 12. So what I've got is x equals -1, y equals 3. That is a point, right? I found the value of both my variables and it's given me a point. And if I were to graph these, and in fact, let's go ahead and graph it. I think I might have closed my Desmos. Let me go ahead and get that open real quick. Sorry for the dead air. I kind of wish I knew how to edit videos, so you didn't have to watch me do this. So let me switch over here. Desmos. So my two equations were things that I have forgotten. 3x minus 2y equals -9. Minus 2y equals -9. That's one of them. And then the other one was x plus 4y equals 11. X plus 4y equals 11. And you can see Desmos actually conveniently finds the point for you automatically. And it's -1, 3, exactly like we said. So I've got my two lines there, and that was the intersection point. That's the one where that we say is a solution. I am going to, in general, write my answers like this. Like I wrote them here on the whiteboard, where I just say like x equals a value and y equals a value. Not because it's wrong to write it like this. It's totally fine to write your answer like this, right? That makes perfect sense, because if we're thinking of these as two lines, and then the point they intersect at would be a point, right? And so I write it as a point, and that's totally fine. The reason I tend to write it like this is because systems of equations like this are very often used in word problems. And so the answer, like what that means is the x and y would represent quantities. They represent things in the real world, or at least in the real world of word problems. And so what you really want to know is often like the two different quantities that you're looking for. And so it can be clearer to write like x equals -1, y equals 3. If you're just thinking of these as lines and you want to know what the intersection point is, it makes perfect sense to write it like this. So determine from context which one you should do. I tend to do this top one. If you want to do the bottom one, that's fine too. If you're going to do the bottom one, make sure it's very clear. Like if your variables are a and b or something like that, don't do it like this, because this really means x and y, like if you write it like this. So if your variables aren't x and y, and sometimes they're not, make sure it's clear which one is which if you're doing it that way. Okay, so that was the elimination method. The idea is that when you add your two equations together, one of the variables gets eliminated if you've done it right. So let's see an example of doing that and having something go weird on you. So I'm going to do x minus 3y equals 6. and minus 2x plus 6y equals 5. Okay, so I'm going to do the same thing. I'm going to figure out what I need to multiply an equation by so that when I add them together, something cancels out. So let's go ahead and eliminate the x's this time. I did the y's last time. So I have an x here and a minus 2x there. And so if this one was a plus 2x, then I could eliminate them. So if I multiply my top equation by 2, I'll get 2x here and be able to eliminate the x's. So let's do that. So my top equation multiplied by 2 gives me 2x minus 6y equals 12. And my bottom equation is minus 2x plus 6y equals 5. And you can probably see what's going to happen here. When I add them together, the x's cancel, but the y's also cancel, right? Minus 6y plus 6y is 0. And so I end up with 0 equals 17. And now I may not know everything there is to know about math, but I do know that 0 does not equal 17. That's false. And what this means is that this is a contradiction. These equations cannot both be true. So what this means is if I were to go graph these in Desmos, and I will, what we're going to see is that we're in that second case of from when we were graphing systems of equations where the lines are parallel. They're parallel and they never meet. So what that means is we end up, when we try to figure out, okay, what's the point they meet at, we get something that's just nonsense. So let's see what that looks like. So I had x minus 3y equals 6. Let's turn these guys off. I had x minus 3y equals 6. And then the other one was a thing that I forgot already. No, I got it written down. Minus 2x plus 6y equals 5. We have minus 2x plus 6y equals 5. Right? And you can see they're parallel lines. They're never going to meet. And so when we try to solve these two equations together, what we get is nonsense. So when you are solving one of these equations, if the thing that you get is logically impossible, right? You get something like 0 equals 17, then that means that there are no solutions to your equation, right? And you could have seen that if you'd started off by graphing these, which, by the way, is not a bad idea to do. If you have access to a calculator or a computer or whatever, and presumably you have one or both of those, it's certainly not a bad idea when you're solving a system of equations to kick it off by just typing this into your calculator and seeing what the graph looks like, right? And then you'll know right away, oh, I see two parallel lines. There's going to be no solution here. Now, certainly go through the algebra. I will absolutely ask to see your work on all the problems you do. So you still got to do the algebra, but you'll at least know what to expect. And this is an excellent way to check your work, right? Like if you do a bunch of work and you get an answer that is not the same thing as the answer in your graph, one or both of those things, something has gone wrong somewhere, and you can rectify it to try and redeem your star somewhere. Yeah, but that's the idea. So when you get nonsense like this, that means that there's no solution. All right, let's see the other method, substitution method. So the substitution method uses the same goal. So the goal in the substitution method is the same as the goal in the elimination method, which is to get rid of one variable, so that what we have is an equation in one variable that we can solve. But it does it very differently. So what do I want to use here? Let's see, 2x minus 5y equals 5. And 10y equals 3x minus 6. Okay, so with the substitution method, the idea is that you want to solve for one of the variables and plug it into the other equation. And I'll show you what I mean by that. I want to get either x or y alone in either of these equations, and it does not matter which one you do. Some will be easier than others, but they will all work if you do it correctly. And then plug that in, and I'll show you what I mean by that, and then solve the resulting equation. So of all the variables that I see here, none of them look like a great choice. Yeah, none of them look like a great choice. So I'm just going to pick whichever one has the smallest coefficient, which is this 2x here. And I'm going to get the x alone. Like if I'm going to solve for it, like if I was putting a line into slope intercept form. So in that equation there, I'll move my cursor here. So I'm going to have 2x minus 5y equals 5. So I'm going to move the 5y over to the right. So I'll have 2x equals 5y plus 5. I shouldn't say move. I'm going to add the 5y to both sides. And the result will be this thing that you see here. Then I'm going to divide everything by 2. And that is going to give me fractions. And that's too bad, but sometimes you get fractions. All right. So now that I've got x alone, what I'm going to do is notice that I need both of these equations to be true at the same time. That's what solving a system means. And so x is this. X is 5/2 y plus 5/2 at whatever point I'm talking about, or at my solution point, because this is one of the lines, right? And so this line goes through my solution point, and everywhere on the line, this is true. So what that means is I can take this x right here and put it in to the other x in the other equation. Right? Those x's are the same x. But I don't want to actually put in x. What I want to put in instead is this. That's going to substitute for x. That's what's called the substitution method. That's going to substitute for x in that equation. So let's do that. So let's go back to black here. What I'm going to get here is this 10y equals 3 times 5/2 y plus 5/2 minus 6. Right, so what I did was I just used this equation right here, and instead of x, I wrote in a thing that is equivalent to x, and we know that because x equals this, right? And so that's what I'm going to use for my x. Now you might say, this looks much worse, right? This does not look like an improvement on the previous equation. And that's true, it's messier, but the value here is that it's only got one variable. There's no x's left. It's all y's, and so we can solve for that y. And it'll be a little bit messy, but it's not super hard. So let's just go ahead and do that. 10y equals, and I'll distribute the 3, so I'll have 15 over 2 y plus 15 over 2 minus 6. I'll go ahead and combine the like terms. So actually, before I combine the like terms, I think what I'm going to do is I'm going to get rid of the variables by multiplying everything by 2. I'm going to multiply both sides of the equation by 2, so that all of my, did I say get rid of the variables? I mean get rid of the fractions, so that the fractions go away. And if you remember back from way back in fractions in the first topic, we talked about the way you could, or I guess solving linear equations, the way you can cancel in an equation, the way you can cancel the fractions is by multiplying by the LCD. Well, the LCD here is pretty obviously 2. So that's what I'm going to do. I'm going to multiply both sides of this equation by 2 before I have to do anything with the fractions. And remember that you get a fresh copy of 2 on all the terms here, so it gets distributed to everything like that. So 2 times 10y is pretty clearly 20y. 2 times 15 over 2 is just 15. The 2's cancel, and we get 15y plus 15 minus 12. All right, that looks a lot cleaner and easier to deal with. So let's subtract 15y from both sides. So we'll end up with 5y equals 15 minus 12 is 3. So y is 3/5. So it looks like we were going to get fractions no matter what we did here. So the answer is a fraction, right? So we weren't just going to have integers the whole time. All right, so I get y equals 3/5, and we have to figure out what x is still. So I'm going to take this 3/5 and put it back into whichever of these equations seems appropriate. Both of them, when I say seems appropriate, that's not a good way to say that. Either one's fine. Use whichever one you feel like. I'm going to use the one on top because it seems to have smaller numbers. So that might make it the calculations a little bit simpler. So I'm going to get 2x minus 5 times 3/5 because that's the value of y. This process is called back substitution, by the way. When you take this number that you found and substitute it back into one of the previous equations. I'll go ahead and distribute. I think I'm running out of room here. I'm going to rewrite this on the next page. So we got 2x minus 5 times 3/5 equals 5. So we have 2x minus 5 times 3/5 equals 5. So let's multiply this out. So we get 2x, 5 times 3/5, 5 over 1. So those cancel. Minus 3 equals 5. Add 3, 2x equals 8, and x is 4. So my answer is x equals 4, y equals 3/5. Let's see if that agrees with what it looks like on a graph. So let me go back to the original equations where 2x minus 5y equals 5. I've got it written down over here. Yeah, so let's go look at Desmos. Turn these guys off. We get 2x minus 5y equals 5. That's 1. And then the other one was 10y equals 3x minus 6. 10y equals 3x minus 6. And then our answer is 4 and 0.6, which is 3/5. So x is 4 and y is 3/5 was our answer here. And I believe that was our answer on the whiteboard as well. Yes, sir. X is 4, y is 3/5. So as we expected. So that's looking good. All right, let's try substitution method in one of the strange cases. So this is gonna be a little bit messy looking, but that's okay. This will be not so bad actually. 1/2 x plus 3y equals 1. No, not 3y. It's 1/3 y. I got to get that right, or this will come out confusing and wrong too. 1/3 y equals 1, and then I've got minus 3x minus 2y equals -6. Now, there's a few good options for what equation I would like to, or what variable I would like to substitute in for. But the first thing I want to do, I think, is get rid of the fractions. So one of the nice things in systems of equations is they're equations, and so you can multiply both sides by whatever you want of any equation, as long as it's the same thing, of course. And that will that'll be fine because you're just doing the same thing to both sides of an equation, which doesn't change whether it's true or not. So to get rid of the 1/2 and the 1/3, I think what I really want to do is multiply both sides of the top equation by 6 before I even do anything else, right? Before I even decide what method I'm going to use, although I've already decided it's going to be substitution. I can get rid of the fractions and see if that tells me anything. So if I multiply the top equation by 6, and don't forget to do the right side, by the way, it's super easy to just multiply the left side by 6 and then forget about the stuff on the right. Don't do that, of course, it'll ruin your problem. So the 6 gets distributed here. So half of 6 is 3, so I'm gonna get 3x. And 1/3 of 6 is 2, so it's gonna be 2y equals 6. And then my other equation was minus 3x minus 2y equals -6. And I think it's pretty clear that if we were doing the elimination method and I added them together, I would just get everything going to 0, which is going to be kind of what we do with the substitution method. I'm going to run through substitution method, even though we kind of know something funny is happening here. I'm going to go ahead and do substitution method anyway, just to kind of see the process. So again, we can solve for whatever equation, whatever variable in whichever equation we want. I'm going to go ahead and solve for the y in the first equation here. So if I have, let's go here, 3x plus 2y equals 6. So I'm solving for y. I'm going to subtract the 3x over. So we get 2y equals minus 3x plus 6. Divide by 2. Y equals minus 3 over 2x plus 3. And then what I'm going to do is I'm going to take that y and put it into the other equation, just like I did before. So I'm going to get minus 3x minus 2 times minus 3 halves x plus 3 equals -6. So let's go ahead and distribute my -2. Minus 3x minus 2 times minus 3 halves. The minuses cancel, the 2's cancel, leaving me just plus 3. So plus 3x. And minus 2 times plus 3 is -6 equals -6. And lo and behold, minus 3x plus 3x cancel, and I get -6 equals -6. And very similar to this guy over here, that's a funny looking equation, right? This one's always false, but -6 equals -6 is always true. So all that means is that these two are actually the same line, which you can really tell. Like if I just multiply this one by -1, I would get that one, right? So they're pretty clearly the same at this point. But what you'll get when you're doing substitution method is you'll get basically all the variables canceling out when something like this happens. So let's go see what these look like. If I were to go to Desmos, half x plus a third y equals 1. Let's flip over to Desmos. Okay, so a half x plus a third y equals 1. Is that line? And then the other one was minus 3x minus 2y equals -6. And you can see that that is indeed the same line, right? The green line is laying right on top of the blue one. It's hard to see when I switch the blue one, but it's easier when I do the green. So those are the same line, right? So this has an infinite number of solutions, and the solutions are anything that's are any point on either line is a solution to the system of equations. So there's an infinite number of those. Okay, so, oops, that is not the right thing I wanted, that I was aiming at. I was going for the whiteboard here. So those are basically all the situations you can get into. When you're solving a system of two equations with two variables, you want to do either substitution or elimination. They both always work. Like you can always do either one. I think maybe I want to show you one more elimination because I did ones that were kind of too simple here. And I didn't show you the most complicated case. So I think maybe I want to do that too. I'll get to that one in a second. But these are the two situations you can get into. These are the two choices you have. You can either do substitution or elimination. You can always do either one. They always both, if one works, the other one will work. And then you can have one solution, or you can have no solutions, or you can have an infinite number of solutions. One solution means that you will just get some numbers, right? You'll get numbers like this. This is one solution. These two lines, if I were to graph them, they just cross at a point. We actually saw that. On the other hand, if you get something weird like this, something weird and always false, that means that there are no solutions. If you get something weird and always true, like this, that means that there are an infinite number of solutions. And that's really all you need to know about solving systems of equations by substitution and elimination. Although I will do one example of a harder elimination question. I'm just gonna pause the video, come up with an example because I don't have one ready, and you don't want to just make these up on the fly. So I will be right back. And I'm back. All right, so I've got myself a nice little example here that I'm gonna do for you. So let me whip up the, go to the whiteboard here and whip up an example for you to see. And you'll see why it's a little bit harder than the other ones that we were doing before by elimination. So the example I've got here is 2x minus 5y equals negative 14. And 3x plus 4y, 3x plus 4y is 25. And those numbers don't look too bad. I mean, negative 14 and 25 are large-ish, I guess, but nothing looks too bad here. So why is this harder? Well, this is harder because if you look at the elimination questions that we did over here, it was always pretty easy to turn one into the other, right? I could multiply this one by 2 to turn the negative 2y into a negative 4y and then cancel the 4's. I could also have multiplied this bottom equation by negative 3, so that I'd have negative 3x and positive 3x, and they would cancel. That would work fine. I could also, when I was over here, it was pretty easy to do, right? I just multiplied the top equation by 2, and I got minus 6y and 6y. And you might notice that it's not obvious what you can multiply by here, right? And so what you end up having to do is multiply both equations. And so the easiest way to do this that I know of is to find the least common multiple, which is just like least common denominator, but without fractions, of either the x's or the y's, and turn both things into that. And so I think it's going to be easiest to eliminate the x's here, because the least common multiple of 2 and 3 is 6, and that's relatively small, whereas the least common multiple of 5 and 4 is 20, and that's relatively large and would require some bigger numbers. So I'm going to do the smaller one, right? If I'm going to have to multiply both equations by something, I want it to be something relatively small. Now, the least common multiple, so the smallest number that both 2 and 3 go into evenly, is 6. So I want to turn these both into 6's, but I want one of them to be negative, so that when I add them together, it cancels out. It does not matter which one you make negative, just one of them has to be. So I'm going to multiply my top equation by 3 to turn the 2x into a 6x. And of course, I have to do that on both sides. And I'm going to multiply my bottom equation by negative 2. So that I have a negative 6x in my bottom equation. So let's do that. Multiply the top equation by 3, I get 6x minus 15y equals negative 42. Multiply the bottom equation by negative 2, and I get minus 6x, which is, of course, what I wanted, minus 8y equals negative 50. And now when I add them together, the 6x and the minus 6x cancel out. Minus 15 minus 8 is minus 23. My right side is minus 42 minus 50 is minus 92. Now, I don't know how many of you know this, but 23 goes evenly into 92. It goes in 4 times. So what I have here is y equals 4. Now you could certainly use a calculator for that if you'd like to. So y equals 4. So now I have to plug that back into any of the previous equations that I used that have both x and y. Now, interestingly, I could use these equations if I wanted to, but these have smaller numbers, so I'm going to use them. It doesn't really make any difference which one I do. I'll choose the second one arbitrarily. It really makes no difference. So I'm going to get 3x plus 4 times y is 4 equals 25. So I get 3x plus 16 equals 25. Subtract 16 from both sides, and that gives me 3x equals 9. So x equals 3. So there's my solution. Y equals 4, x equals 3. Now, let's go ahead and graph these just again. as a quick check to make sure that everything is going okay. So Desmos, and we're going to get put these guys off. Go 2x minus 5y minus 5y equals negative 14. And 3x plus 4y is 25. 3x plus 4y equals 25. And my answer is 3, 4. X equals 3, y equals 4, which is indeed what I found. X equals 3, y equals 4. Fantastic. Looks good. Looks like we found the right answer there. So when you're doing elimination, sometimes you have to multiply both equations by something to make one of the variables cancel out. So the way you identify what you are trying to turn them into is either pick X's or Y's, and it doesn't make, well, I don't want to say it doesn't make any difference. You can choose either one. You can always choose either one. One might be easier. I think the X's were a little easier just because the numbers were smaller. So that's why I chose the X's here. The number you want to turn the coefficients into is the least common multiple of the coefficients. And I know that was a little bit complicated, but the smallest number that both 2 and 3 go into is 6. So I wanted to turn them both into 6. One positive, one negative. Doesn't matter which one's negative, make it either one. And then once you do that, then you'll add them together. You add the equations together, of course, and you go from there. But that's how you can tell what you want to turn these into. It's the least common multiple. And then how to do it, right? You multiply by whatever you need to turn it into the appropriate multiple, right? So since the least common multiple of 2 and 3 is 6, well, I need to multiply 2 by 3 and 3 by 2 to make 6. So there you go. That's really all I want to say about solving equations by substitution and elimination. This is definitely a thing that you want to practice, right? It's a little bit complicated. It's not as straightforward as just solving a linear equation. There's really a process that you kind of got to go through. So, but on the plus side, it is one of those processes that if you do it a few times, it's really not that bad, right? I know it looks complicated now, but that's probably just because you haven't seen it too much before. Once you do it, 3, 4, 5 times, it's really not too bad at all. And yeah, with that, I will go ahead and stop the video here since that's all I wanted to say. And I will see you guys in the next one.